Hello, my name is Ivan Fetch, and I'm a site reliability engineer with Fairwinds. I'd like to talk a bit about managing applications in Kubernetes using Helm, the Kubernetes package manager. Helm helps you install, upgrade, and roll back applications in Kubernetes. You can use Helm's templating and hooks to vary how an application gets installed across multiple environments of your Kubernetes clusters. This Helm demo will use our Fairwinds Polaris application, which compares a Kubernetes cluster against Kubernetes best practices. This demo focuses on the Polaris validating webhook, which will deny the installation or upgrade of a resource to Kubernetes that doesn't meet Polaris standards. For additional information about Polaris, including its dashboard, please see the link in the video description below. I've already gone to the Helm website, helm.sh, and followed the installation instructions to install both the Helm client on my laptop and the Kubernetes component called Tiller. You can see those commands on my screen where I create a service account, create a cluster role binding for that service account, and use the Helm init command to install Tiller in my cluster using the above service account. First, I need to tell Helm where it can find the chart, which is what Helm calls a package, for the Fairwinds Polaris application. I'll do this by running the Helm repo add command, passing it the name I'd like to give the repository, and the repository's URL. Next, I'll install Polaris by running Helm Install name Polaris, namespace Polaris, and then Fairwinds stable /Polaris. The -- name flag sets what Helm calls a release, which is a distinct installation of a Helm chart. The Fairwinds stable /Polaris portion represents the Helm repository I just added and the name of the chart to be installed. I can see, having run kubectl get pod-n Polaris, that the Polaris dashboard pod is already running. Each Helm chart has a values.yaml file, which defines default and possible values you can specify for the Helm chart. I've already used the Helm fetch command to download the chart for Polaris. Let's take a look at the Polaris values file. At the top, here's the configuration section where Polaris checks are defined that will be run against your Kubernetes cluster. Let's look at the image tags check. Here I see that if the image tag is not specified, it's considered an error, which means that the Polaris validating webhook will refuse to allow any deployments to be installed or upgraded in the cluster that don't have a tag set for their image. Next, let's look at the webhook configuration. I see that webhook.enable is set to false, which means that by default, the webhook will not be installed. Looking at the top of the Polaris webhook deployment Helm template, I see an if statement in double braces that says if.values.webhook.enable, below which is the Kubernetes manifest for the deployment. This is a simple example of how Helm templating can be used to optionally include a Kubernetes resource. I'll upgrade our installation of Polaris to enable the webhook by running Helm upgrade Polaris Fairwinds stable /Polaris -- set webhook.enable equals true. Having run kubectl get pods again, I see that the Polaris webhook pod is in the process of being created. I have a Kubernetes deployment which doesn't include a tag for the Nginx image. If I attempt to apply that, it'll be rejected by Polaris because it's missing an image tag. I then diff that deployment with a second deployment, which includes an image tag. Applying the second deployment succeeds. When specifying a lot of values for the installation or upgrade of a Helm chart, it's easier to use a values file similar to that comes with charts. Let's look at a custom values file I've created for Polaris. At the top, I've enabled the webhook as we've already done, and below that, I've copied the entire Polaris configuration section so that I can update some of the checks. I've changed the CPU requests missing check from warning to error, so that if I attempt to add a deployment to Kubernetes without a CPU request, the deployment will be rejected by Polaris. It's also possible to use a local copy of a Helm chart when installing or upgrading. I'll upgrade this Polaris installation with our local values file and using a local copy of the Polaris chart by running Helm upgrade Polaris -- values myvalues.yaml, and then Polaris again, which is the local copy of the Helm chart. If I delete and reapply the second Kubernetes deployment that succeeded earlier, It will now fail because although it contains an image tag, it doesn't contain any CPU requests. I'll then diff that deployment with the third one, which among other things contains CPU requests. Applying that third deployment succeeds. The Helm ls command shows the Helm releases that have been installed, including the version of the Helm chart and version of its application. The Helm history command shows the different revisions for a Helm release. The Helm Get Values command shows the values I specified during installation or upgrade of the Helm chart. I've run Helm Get Values Polaris revision 1, which shows an empty set of braces because I didn't specify any values when I first installed Polaris. Looking at revision 2 of the Polaris release shows webhook enabled is set to true. Running Helm Rollback Polaris 1 rolls the installation back to revision 1 of the Polaris chart. This means that the webhook will no longer be installed. Running kubectl get pod-n Polaris shows that only the dashboard pod is running. There's not much use to install Polaris multiple times, but I'll use a Minecraft server to demonstrate multiple installations of a Helm chart even in the same namespace. I'm running Helm Install set Minecraft server EULA equals true to agree to the license agreement, then stable/Minecraft for the repository and name of the chart, and --name MC1 to name the release MC1. I'm doing the same thing with a name MC2. And now when I run Helm ls, we see 2 releases or installations of Minecraft server. If I run kubectl get pod, in addition to the Nginx pods we worked with earlier, there's 2 Minecraft server pods with the name MC1 and MC2 as a prefix. Check out the Helm Hub to find charts that you can install in your Kubernetes cluster at hub.helm.sh. To get started creating your own Helm charts, use the Helm create command to create a chart that you can edit. I've run Helm create special app and then looked at some of the contents of that directory. I see that it creates a values.yaml and a chart.yaml, which contains metadata about your chart, and within the templates subdirectory, an initial ingress, deployment, and service for you to get started with. Thank you for watching. Here are some of the links that I've referred to in this video, including Helm, Helm Hub, Fairwinds Polaris, and the chart for Minecraft.